I'll start this video with question I. We're asked to identify the domain of the function square root of quantity 5 minus x over x minus 4. And since 4 makes the denominator 0, 4 is a 0 of the denominator, x cannot be equal to 4, so x is not in the domain. But we also need to look at the radicand, what's underneath the radical. So because this is an even indexed radical, it's a square root, that means that this radicand must be non-negative. It's in the numerator, so it can equal 0, but it cannot equal any negative number. So we set that radicand, 5 minus x, greater than or equal to 0, and solve for x. So we add x to both sides, and then because the standard is to have the variable on the left side of an inequality, we conclude that x is less than or equal to 5. So the domain is the set of all x such that x is in these two intervals, negative infinity to 4 with the curve parenthesis there to indicate 4 is not included, union 4 to 5. So since this is greater than or equal to, less than or equal to, 5 is included. 4, though, is not because x cannot equal 4, so we have the parenthesis, the curved bracket here. All right, question J. Question J asks us to compose f with g, and this is a pretty simple composition because f, being here to the left, is the outside function, so that means wherever we've got an x in that function, we put a set of parentheses, and inside those parentheses we substitute in the other function we're composing it with. So we have a set of parentheses here for this x. So this, whatever's in there is squared. Well, it's a square root. So we put this function in the parentheses. The square root of a square cancels out. Those two operations cancel one another out. So this is just x minus 2. And then x minus 2 plus 4 is equal to x plus 2. The domain of this function is all real numbers. I didn't put that here. I will add that to the document for the that I will give to you in class and post online, but it's just a linear function, and the domain is all real numbers. So question K, we're asked to find the inverse of this rational function, 2x over 3x minus 1. And so we remember our steps. We write y for f of x, and then interchange the x and y, and then solve for y. So I've done the interchanging x and y here, and I multiply both sides of the equation by 3y minus 1 to clear the fraction, and so I have x times the quantity 3y minus 1 equals 2y, the numerator here, and I distribute the x so that I have 3xy minus x equals 2y. I want every term that has a y in it on one side of the equation, so I subtract 2y from both sides and I add x to both sides. Then I factor out a y. Y factored out from these two terms leaves y times the quantity 3x minus 2, and then I multiply both sides of the equation by 1 over 3x minus 2. That gives me y is equal to x over 3x minus 2. Then I write f inverse of x for y. And we're asked to determine its domain. We're not asked to verify, but we're asked to determine the domain. And so we see that it's just a rational function. The numerator can be anything, so we just have to find the zeros of the denominator. So we set that equal to 0. 3x minus 2 equals 0. Add 2 to both sides and divide by 3. So the domain of the inverse is the set of all x such that x is not equal to 2/3. All other values are included in the domain. Alright, question L is a multi-part question. We're asked to make several evaluations and come up with some solutions. The first one's probably the trickiest. Log base 2/3 of 16 over 81. Well, I have converted this to its exponential equivalent. And remember, that means that I bring the x, or whatever's on this side, over here as the exponent for whatever this base is. The base is 2/3, so that's 2/3 to the x. And then I take the argument and bring it over to the right side. So 2/3 to the x is equal to 16 over 81. Now hopefully I can, and I can, write the numerator here with a base of 2, and the denominator here with a base of 3. So 16 is 2 to the 4th, and 3 is 3 to the 4th. And so that means that I can pull the 4, I can sort of rewrite this as 2/3 raised to the 4th power. And so that means that the x is equal to 4. That one's a little bit tricky. I don't really know if the question on the exam is that tricky. Alright, now for part B, we're just writing both sides with the same base. 27 is 3 cubed, so I write that here. I put it inside parentheses, and then I bring the 3 out and multiply by the exponent. So this is then 3 to the 6x. Now I set the exponents equal to one another. X squared minus 7 equals 6x. Subtract 6x from both sides and factor. So x plus 1 times x minus 7 tells us that the solutions are x equals -1 and x equals 7. Alright, for part C, this just requires writing. This is pretty simple. The next two are pretty simple. We just rewrite this in exponential form, making the 1/2 the exponent of 16 and bringing the x to this side. 16 to the 1/2. To the 1/2 means square root, and the square root of 16 is 4, so x is equal to 4. And then part D is so simple it might as well not have even been included. Log base b of b raised to any exponent clears. These operations are inverse of one another, so that just leaves 9. Alright, and question M. So in question M, we're asked to sketch a graph of a translated logarithmic function. Now, when we were sketching, or analyzing rather, functions with a base of e, we only kept track of the x-intercept to see where it moved. But for with a different base, there's probably 2 points we should keep track of. And I've got log base 2 of x here for your comparison. So we would draw this asymptote, the vertical asymptote here, and draw a line 1 unit to the right and see that the function intersects right here, and that's 3 units to the left and 1 unit up from where the x-intercept was. But log base 2 has a function value of 1 at 2. So we can also, we also probably want to know where that point was translated to. And so we know that from looking at the vertical asymptote that it's 3 left and 1 up. And so we move that point here, 3 left and 1 up. And then if we want, we can put some values in here to get other points. But that might be enough to sketch a rough graph coming up through this point here, which was the x-intercept translated, and this point here, which is the point that gives us a function value of 1. And then, as I said, we could probably come up with a couple of other values. 5 looks like a good one. 5 plus 3 is 8. Log base 2 of 8. Log base 2 of 8. That is the number we raised 2 to get 8, and that's 3. It's 3, but we're adding 1, so that shifts us up to 4. So we draw, sketch a graph through those points and come up with a reasonable graph.